Hi guys, welcome to my first video of 2022, and I'd also like to wish you guys a happy, prosperous 2022. Okay, so this is gonna be a linear algebra video, and solving a system of equations using Cramer's rule. Okay, and the same system of equations is the ones that I've used on my video using the reduced row echelon form. So check out my videos just using the same system of equations, and this is just to show you that we can use different methods to solve mathematical problems. Okay, so same equations I had earlier on, and minus x minus 2y minus 3z equals minus 4, and then 3x plus 2y plus z equals 8. Okay, so then I'm going to put that into augmented format. So that's minus 7, minus 1, minus 5. Let's go to minus 15, minus 1, minus 2, minus 3, minus 4, and 3, 2, 1, and 8. So that's augment matrix. Okay, right. So yeah, like I said, it's the same system of equations I used in my reduced row echelon form method. Okay, right. So my first step is to I'm going to find the determinant of this part of the matrix. Okay, so I'll call that matrix M. So minus 7, minus 1, minus 5, minus 1, minus 2, and minus 3, and then 3, 2, 1. Okay, I'm going to use the diagonal method to find the determinant. So therefore, minus 7, minus 1, minus 5, minus 1, minus 2, minus 3, 3, 2, 1. And then minus 7, minus 1, minus 1, minus 2, then 3, then 2. Okay, so these diagonals, okay, multiply those diagonals with the green writing, and then also multiply these ones as well with the blue writing. So the ones with the green writing, multiply them together and then subtract the product of the blue writings. Okay, right, so determinant M equals so minus 7 times minus 2 times minus 1, so which is that? Okay, so you just carry on doing the same thing. And then that'll be 3 times minus 2 times minus 5. So that's that lot there. And plus that. So it will be 2 times minus 3 times minus 7 plus 1 times minus 1 times minus 1. Okay, so simplifying further. So that'll be, oh sorry, my bad. That's a 1 times 1, not minus 1. So that'll be 14, yeah. That's 9, and that's 10. Yeah, and then so that's 30 plus 42 plus 1, and that's equal to, so simplifying that further, that'll be minus 40. So that's the determinant of m, right? So the next stage is find the determinant. Assignment matrix. I'll call it mx. So what happens here is this column gets shifted to the left and becomes a column. So get rid of that. Get rid of this column. So that becomes that moves from the right to the left and right, and that just goes away, right? So that'll be so minus 15, minus 4, 8, and then minus 1, minus 2, and then 2, then minus 5, minus 3, and then 1. Okay, so essentially my and mz, I'll be moving this column into the, or move for my, I'll just move that column into the middle. Then mz, move this column to the last column, and then then keep solving for the determinants for those matrices. Okay, so therefore minus 15, minus 1, minus 4, minus 2, 8, and then 2, then minus 5, minus 3, 1, and then these two columns will come out, and there'll be minus 15, minus 1, minus 4, minus 2, then 8, then 2. So using the diagonals method as well, so that mx, so minus 15 times minus 2 times 1 plus minus 1 times minus 3 times 8 plus minus 5 times minus 4 times 2, right? Then subtract these diagonals here. So the product of these diagonals, right? So that becomes so 8 times minus 2 times minus 5 plus minus 15 times minus 3 times 2, then plus 1 times minus 4 times minus 1. Okay, so simplifying further, we get 94 minus 174, which is minus 80, which is the determinant of a matrix mx. Then my, right, so that's minus 7, minus 1, and then 3. And like I said, remember I said this column will now move into the middle, so that'll be minus 15, minus 4, 8, and then minus 5, minus 3, and then 1. And just following the same step as well, you know. So minus 7, minus 1, 3, minus 15, minus 4, 8, minus 5, minus 3, 1. And then these two columns come out. So minus 7, minus 15, minus 1, minus 4, 3, and 8. So the determinant of my is minus 7, 4 times 1 plus minus 15 times minus 3 times 3 plus minus 5 times minus 1 times 8. Then subtracting the product of these other diagonals, the sum of the product of these diagonals. So 3 times minus 4 times minus 5. Yeah, so 8 times minus 3 times minus 7. Yeah, just double checking. And then 1 times minus 1 times minus 15. Okay, and then simplifying further, we get 28 plus 135 plus 40 minus 60 plus 168 plus 15, which is 203 minus 243, and then we get minus 40, right? And then sorting out the last matrix. So mz, so minus 7, oh sorry, oh yeah, so minus 7, minus 1, 3, and then minus 1, minus 2, and then 2, and then minus 15, minus 4, 8. Right, so finding the determinant of mz. So minus 7 times minus 2 times 8 plus minus 1 times minus 4 times 3 plus minus 15 times minus 1 times 2 that's minus 2, sorry, times minus 15 plus 2, so this diagonal here, times minus 4 times minus 7 plus then the final one, which is that 8 times minus 1 times minus 1. Okay, so that'll be so 112 plus 12 plus 30 minus 90 plus 56 plus 8, which is 154 minus 154, which equal to 0. Okay, so now doing the last and final step. Right, so the value of x will equal so the determinant of mx divided by the determinant of m, right? So that's minus 80 divided by minus 40, which is equal to, okay, so the determinant of yeah, so that's minus 80 there divided by that of m, so minus so that's 2, and then y equals determinant of my divided by determinant of m, which is minus 40 divided by minus 40 equal 1, and then the last one, so determinant of mz, determinant of m. Obviously you can't, that's obviously going to be a big 0. Okay, so those are the values of the system of equations. So just to check that these values are correct, I'll just do a quick check. So minus 7 times 2 minus 1, and then since we know that z is 0, yeah, so that's minus 14, sorry, minus 15. Okay, so minus 14 minus 1 is minus 15. Okay, and that indeed satisfies our equation, yeah? And then the next part, the next equation, so that's so minus 2 times 1 minus 0, and that's minus 4. So indeed it satisfies that equation as well. Then the final one, so that'll be 3 times 2 plus 2 times 1 plus 0, which is 8. So there we are. So yeah, So that's using the Cramer's rule to find solutions of unknown variables on a system of equations. Okay, so yeah, hopefully this was helpful, and hope you guys have a good 2022. So yeah, peace to you all. Peace. And thank you.